Hello everyone. This video is about motion and particle models, of course displaying acceleration. We'll explore how motion diagrams show when an object speeds up or slows down and how to display acceleration on a motion diagram. So let's start with the motion diagrams of a runner recorded at equal time intervals. In this first picture, there is only one figure, like a runner waiting for the signal at the start of the race. Time passes here, but the position does not change. It means the runner is motionless, or we say in physics at rest. The second picture shows several figures equally spaced, equal distances in equal times, means uniform motion. Here the speed is constant and there is no acceleration. So again, this is uniform motion. In the third picture, the spacing between positions increases from left to right. The runner covers more distance in each equal time step. So the speed is increasing here. This is, of course, a non-uniform motion with acceleration. Here we say in the direction of motion or in the direction of speed. Here we are speeding up. And the last picture, the fourth picture, shows the spacing decreasing here. The runner here covers less distance each time. So the speed, we can say the speed is decreasing, and this is also a non-uniform motion, but here the acceleration points opposite the motion. Now let's look at the particle model motion diagram and see how it shows changes in velocity. As you know, each dot represents the position of the object at equal time intervals. There are two main indicators of changing velocity. The first one is the spacing of the dots, and the second is the length of the velocity vectors. Here, as you can see, when an object speeds up, each subsequent velocity vector is longer. You see it's becoming longer and longer. And the spacing between dots increases. So you can see this in this diagram where the jogger's speed increases as the dots spread. So here, speeding up. And when an object slows down, each velocity vector becomes what? Shorter here in this case, and the spacing between dots decreases. In this diagram, the jogger slows down and the dots move closer together. Now let's learn how to draw the acceleration vector on a particle model diagram. Acceleration of an object is the rate at which its velocity changes. Okay, so if I want to find it for constant acceleration, which is alpha, equals to delta V over delta T, or we can say the change in velocity delta V, which is the final velocity minus the initial velocity over the delta T, the duration. Now, in this figure, we can see a particle motion diagram for an object with increasing velocity. Notice that the red velocity vectors get longer from left to right. Now, to draw the acceleration vector, first draw the final velocity Vf. I want the acceleration here, finding acceleration vector. You have to draw the final velocity Vf. Below it, you draw the initial velocity, which is Vi, with its tail. You see its tail aligned with the tip of Vf. This is the tip of Vf. It's aligned to the tip of Vf. Next, draw the vector delta V from the tail of Vf. This is delta V from the tail of Vf to the tip of Vi. To the tip of Vi. And the acceleration vector alpha is the same as delta v here, of course, divided by the time interval. Now it's your turn to think. Answer the following question and show what you have learned about motion diagram, particle models, and acceleration.